Hello everyone, I am Sheila, Assistant Professor, Department of Computer Applications. Welcome to the session. Today we are going to see about operating system. An operating system acts as an intermediary between the system resource and the user. There are two views, user view and the system view. User view is the one which the user will see the system, how we are giving instructions to the system. System view is more like how the system is interacting, how the system is working within. That is about the system view. Types of systems: there are mainframe, desktop, multiprocessor, distributed, clustered, and handheld systems. Handheld systems are mobile operating system. Mainframe systems are batch systems, multi-program systems, time sharing, and multitasking systems. Distributed systems are more like client-server architecture and peer-to-peer system. Real-time systems are hard real-time system and soft real-time system. User-oriented services are more of interfaces, a command and interface, a batch interface, and a graphical user interface. Program execution, I/O operations, file system manipulation, communication, and error detection. System-oriented services are resource allocation, security, accounting. System call. A system call is a mechanism. It is a request service that is given by the user to the system. Kernel is the core of the operating system, responsible for process management, memory management, file system, and hardware communication. It operates at the lowest level, managing system resources, ensuring stability and efficiency. Process and scheduling. A process is an instance of a program that is being executed by a computer. Process in memory will have details like text, data, heap, and a stack. This is a process control block. A process control block will have every detail that is regarded to the process: a pointer, a process state, process number, process counter, register, memory limit, and list of open files. There are states of the program: new state, ready state, waiting state, running state, and end, terminated. Terminology is used in CPU scheduling. Arrival time. This time mentions when the process is arriving into the ready queue. Completion time, when it says the time that is for when the process is completion or its execution. Burst time required by a process for CPU execution. Turnaround time is the time difference between the completion time and the arrival time. Waiting time is turnaround time minus burst time. Scheduling queues, there are three process schedulers: long-term scheduler, short-term scheduler, and medium-term scheduler. Context switching, the state saves of the current process. When the process is already running, the context switching process can switch to another process. It can change the state of the new process. That is called context switching. In IPC, inter-process communication, it uses two: shared memory and message passing system. Scheduling criteria. These are different criteria that is used for a process scheduling, CPU scheduling. CPU utilization, throughput. CPU utilization is how long the CPU is used. Throughput, its efficiency, turnaround time, waiting time, load, average response time. Scheduling algorithms are of two types: non-preemptive and preemptive. Algorithm based on non-preemptive scheduling are first come first served, short job first, priority. Algorithm based on preemptive scheduling are round robin, shortest remaining, priority, preemptive version. Multi-level queue CPU scheduling, multi-level feedback queue scheduling. First come first served, it uses a convoy effect. The process that comes first into the ready queue is executed first, other process had to wait. Round robin is different. It allows a fixed time slice quantum to every process, and a process can use the time slot, and once it is not completed, it goes to the FIFO queue and again waits for its turn for its completion. Achieve synchronization, critical section problem, mutual exclusion, progress, bounded wait. Classical IPC problems, inter-process community problems include bounded buffer problem, producer-consumer problem, reader-writer problem, dining philosopher's problem. These conditions have to be met for a system not to get into a deadlock situation. The process need not wait for a long. Synchronization hardware are mutex lock, semaphores, monitors. Mutex lock is a hardware where when a process is already in a critical section, another process had to wait outside. A process is not allowed to enter into the critical section. If those conditions are not met, a deadlock will occur. What is a deadlock? It is a state in which a set of processes are blocked because it forms a cycle where a process is already holding a resource and another process is waiting for the shared resource. That condition will lead to a deadlock. Deadlock necessary conditions are mutual exclusion, hold and wait, no preemption, and circular wait. If a cycle is formed like this, it causes deadlock. So methods of handling deadlocks are deadlock prevention or avoidance, deadlock detection and recovery, deadlock ignorance. Deadlock prevention or avoidance can be had by mutual exclusion, hold and wait, and no preemption. Deadlock detection, it uses resource allocation graph and Banker's algorithm. Resource allocation graph is a graph table where every time a process is requesting a resource, that the graph is updated so that we can monitor where the resource allocation is not met and where a deadlock will occur. Deadlock recovery, manual intervention, automatic recovery, process termination, and resource preemption. Deadlock ignorance, safe state algorithm is managed. Next, memory management. Memory management is a very important concept in operating system. Memory is the core unit and heart of a computer system. Functions of memory management: memory allocation, memory deallocation, address translation, memory protection, swapping and paging, fragmentation control, support for multi-programming. The hardware that is used for this memory management are base and limit registers. Base register will have the address where the process had to be stored, and limit registers will tell the limit, how many memory units a file can take. Address binding, the association of mapping instructions and data into actual physical memory location is called address binding. Address space, it has two types: logical address space and physical address space. Loading, static loading and dynamic loading. In dynamic loading, a page is loaded or a file is loaded whenever it is really required. Swapping is a very important concept in operating systems. Swapping moves process between main memory and secondary memory to manage limited memory space. Contiguous allocation. Contiguous allocation is a process in which a process is continuously allocated in the memory location. So two types: memory allocation, fixed partition allocation, and dynamic partition allocation. Dynamic partition allocation has four methods: first fit, best fit, worst fit, next fit. First fit is whichever process comes the way, it will take the memory space. Best fit, if a process is small and the memory space allocated is apt for the process to store, then that memory space is taken. Worst fit is it does not care, it actually takes away all the memory and doesn't give any memory wastage will happen. Next fit is more like first fit and best fit. Fragmentation, internal fragmentation and external fragmentation. Internal fragmentation happens when there is a lot of memory wastage in the partition. Compaction is a process in which the unused memory spaces are taken back. That is, we can actually get the space back. That is compaction. Segmentation. Segmentation is used to reduce internal fragmentation. Paging, loading process in a non-contiguous manner. Features of paging: fixed size division. It is dividing the process memory space into fixed units. Hardware support, it uses registers, page table base register, translation look-aside buffer and protection bits. Techniques used for structuring the page table are hierarchical paging, hashed page table and inverted page table. The hash page table uses hash value for the fixed memory paging. Page number, page offset, this is used for the system reference. Virtual memory management. Virtual memory management is a memory management technique used by OS to give the appearance of large continuous block of memory to applications when the memory space is really small in physical memory location. Actually the space is not available, but it gives an appearance that the space is available is very good. Demand paging, it is a technique used in virtual memory system where pages enter main memory only when it is requested. File structure, file system. A file system is method in an operating system used to store, organize and manage files and directories in a storage device. File structure has three access methods: sequential, direct, indexed and indexed sequential. Directory structure is of three types: single level, two level directory, three level directory, acyclic graph directory and general graph directory. Protection, file protection, we can use access methods to access files, which is read mode, write mode, read only mode, view mode, etc. Free space management. Free space management is the concept in which free space that is available after the occupied memory space. When the memory space is used or unwanted memory is retrieved back or deallocated, free space management takes care of it. Vector, linked list, grouping and counting in the different techniques used for free space management. These are various file formats. Input-output system. Input-output management has block devices and character devices. PC bus structure, controllers, I/O transfer, polling and interrupts. Polling is handshaking, it's establishing communication. Kernel I/O subsystem components are buffering. Buffering is temporary memory storage. Caching is storing a copy of memory in temporary storage. Spooling and device reservation, error handling and I/O protection. Kernel data structure has a process table, a file table and inode information. Next is system protection. System protection, these are vulnerable malwares that is available that can cause a destruction to the operating system. Those are virus, Trojan horse, trapdoors, worms, denial of service. Protection and security methods for these are authentication, one-time password and biometrics. One-time password is temporary use. Data encryption. Data encryption is a concept in converting plain text into the encrypted text or cipher text, and then the decryptions are applied, and then the decrypted cipher text is again decrypted to the plain text. This is useful for secret message sharing. Example, an apple. If apple is a word, it can be given another code word, say red fruit. Then it is again cipher text could be numbers, added numbers, and then using cipher text can be decrypted to get the word apple again. A password is a collection of letters, numbers and special characters that is confidential and only the user knows it. Only the user applies the password, enters the password, he gets the access. Otherwise other users are not supposed to use the file or operating system. Thank you all.